Hello everyone, I'm Doug Ferrara with RealTraps, and today we will show you how to get an excellent sound in a typical bedroom size space. With this video you will be able to hear and see how our high-end treatment solutions give the most amazing results in a relatively small room. In our case, 11.5 by 16 by 8 feet. What we have here is the ultimate mixing and mastering setup for a room size you'll find in most homes. It's also ideal for critical stereo listening. Of course, you don't necessarily need this much treatment to get great results. However, for people with the desire and budget for the best, this is the best way to treat a room. With the configuration we are about to show, the room sounds much larger than it really is, and later we will demonstrate how this is possible. If you've ever recorded music played through loudspeakers and played the result through speakers again, you know how distant, boxy, and off-mic this usually sounds. But we will show in a room that's well treated like this one, even after a second pass through your own loudspeakers, the sound remains crisp, clear, and focused. We will demonstrate this using the Zoom H2 portable recorder. The H2 provides a recording that is the next best thing to being there. In fact, I am speaking to you now as recorded by this device. Now let's take a look at what we have installed for treatment in this room. This is our modular freestanding system that requires no mounting and consists of the following components that are all 6 inches deep. 2x2 Mondo traps give maximum bass trapping at the floor wall corners. These also act as a foundation for the traps placed above. 2x4 Mondo traps at the reflection points are the HF style to absorb mids and highs as well as bass. We are also using 2x4 Mondo traps with a semi-reflective membrane behind the front fabric, which increases absorption at low frequencies and decreases absorption at higher frequencies. This allows for sufficient overall bass trapping without making the room sounding too dead. Note that by doubling up bass traps like this, pairs of traps flat against the walls in each corner, less floor space is needed compared to straddling the corners. In addition, twice as much corner surface is treated, 48 inches total trap surface, versus 24 inches. In general, you simply can't have too much bass trapping in a room this size. The more traps you have, the closer you'll get to a flat response, and the more it will sound like a larger room. Bass traps also reduce modal ringing, which is just as damaging as a skewed response, and is also a symptom of small rooms. RealTraps diffusers are used everywhere else, again, to make the room sound larger than it really is, while retaining as much liveliness as possible. Note that these are real QRD type diffusers, but are also designed to act as bass traps that kick in below their effective diffusing range of 800 Hz. Lastly, 4RZ panels are used on the ceiling. For a mixing room, you could probably get away with only 2 in the front, but having 2 more tames the rear of the room if you record the occasional guitar or vocal overdubs. This avoids nasty reflections from the ceiling that may cause flutter echo between the floor and the ceiling, since the floor is reflective. For our measurement test, we will use a DPA omnidirectional microphone. For our listening tests, we will use the Zoom H2 portable recorder. This first graph shows the response in the room with no treatment. The peaks and nulls span a range of nearly 30 dB at low frequencies and more than 60 dB at mid and high frequencies. This is typical of all untreated small rooms. As you can see, adding corner bass traps and absorption at the reflection points, but no diffusers yet, makes a huge improvement. After adding diffusers to the room, the response is improved further at all frequencies. Since the RealTraps diffuser also absorbs bass, the low frequencies are made flatter too. Although this response may not seem very flat compared to what you'd expect from electronic gear, in practice this is about as good as possible for a room this size. Now let's take a look at the low frequency waterfall plots. This type of graph shows low-frequency resonance and decay caused by modal ringing. Here the mountains come forward over time. The front-to-back span is 600 milliseconds. With the room empty, you can clearly see each resonant peak and how long it takes to decay. The peak near 40 Hz is especially troublesome, still decaying at the front edge of the graph. After adding corner bass traps, the response is flatter, with ringing significantly reduced. Even the severe peak near 40 Hz now decays much more quickly. This much improvement at such a low frequency is very impressive for any commercial bass trap. RealTraps achieves such high performance in a relatively thin profile by adding a proprietary membrane behind the front fabric. Adding diffusers flattens the low frequency response further, thanks to their unique bass trapping design. That pesky peak just below 40 Hz is reduced even more, and its decay time is much shorter too. Finally, we'll look at how RT60, or reverb decay time, has improved after adding absorbers and then diffusers. Note how much more uniform the decay times are in each third octave band after adding the diffusers. Having uniform decay times across the audible range is just as important as a flat response. Here you can see how important the role of diffusion is to achieve uniform decay times at mid and high frequencies. Now let's listen to music as recorded in the front and rear of the room, with and without treatment. When we listen in the front, we will compare the room empty versus fully treated. However, when we listen in the rear, all the absorption will be in place to compare diffusers versus bare walls. This lets you hear how well diffusion reduces the hollow, off-mic sound you'd otherwise have with the sidewalls untreated. The difference is subtle, but very real.
Okay, so I connect the drum machine to the sequencer, and the sequencer goes to the synth, and then, oh no, the pains are coming back! Okay, so I connect the drum machine to the sequencer, and the sequencer goes to the synth, and then, oh no, the pains are coming back! drum machine to the sequencer, and the sequencer goes to the synth, and then, oh no, the pains are coming back! Okay, so I connect the drum machine to the sequencer, and the sequencer goes to the synth, and then, oh no, the pains are coming back!
For RealTraps, this is Doug Ferrara. Thanks for watching.